Alright, hello, good afternoon, good to see you. Alright, so let's continue our talk with systems. Yesterday, or a few days ago, whenever you did the day's previous work, it was just all practice with graphing lines because we needed some practice doing that before today's lesson. We need to know how to graph lines in order for us to even try to be successful for today. So if you haven't done so, make sure you do yesterday's practice with graphing, and please reach out to me if you need help before this lesson. So last week we talked about figuring out whether an ordered pair was a solution. So we plugged it into the equation, got a true statement, and we said, oh, 8 does equal 8, so this point is a solution. Well, then I showed you if we graph a line, 3, 8 created this blue point, which ended up being on our line. So we had this conversation about how any point that falls on this line here is a solution. So 0, 2 would be a solution, 1, 4 would be a solution, 4, 10 would be a solution. My line represents all possible solutions to this specific equation here. Okay, so early last week we learned that points that are on a line are solutions to that equation. Now this works for a system of equations too. Remember, a system of equations is just when we have two equations with the same variables. Now, the solution, if a point is on both lines at the same time, it is a solution to the system of equations. So instead of having one point land on one line saying it's a solution, or any of these points are a solution, we're looking for a point that is at the same, or that is on both lines at the same exact time. So let me just kind of bring it back to this story problem we've done last week as well. So we did this problem where Ishmael was a private math tutor who charged $20 per hour and then $5, and then we had homework helpers. We created equations to represent both Ishmael and homework helpers, and then we created a table here to represent the cost that they would charge to tutor you, depending on how many hours you wanted their help. Okay, we looked at this table, and we found the solution for this table. Does anybody remember what the solution for this one was? Well, I'm just talking to you, not everybody. So the solution was this point right here. We could see that 2 hours and then 45 and 45. So we saw that when they both had the same y value, that was the solution. So our solution was 245. Okay? Again, if a point is on both lines at the same time, so you can see here at the same time at 2 hours, both of these costed 45. So that was the solution. Now let me graph this for you so we can make this a little clearer and so you can see where to find the solution on a graph. So I'm going to graph Ishmael in pink, and then I'll graph homework helpers in green. So I'm going to go through and just plot these points. You can pause me and do it, or follow along with me. So we have the point 0, 5. 0 is right here. So 0, that goes by 2. So 2, 4, 6. 5 is in between 4 and 6. Then we have 1 and 25. Again, between 24 and 26. 2, 45. Right here. And then 2 or 3 and 65. That's going to be slightly off my screen. I'm just going to estimate it to be right there. And now I'm going to go ahead and make that into a line. Let me try to move that line a little bit closer over the top here. Ooh, come on. Maybe I can't. Oh, wait. Okay, that was a little bit better. Okay, that's slightly better. Okay, so there's Ishmael. Now we'll do homework helpers in green. So we had 0, 25. So at 0 hours, they cost $25. which was the same for 1 hour. For Ishmael, at 1, it costs $35. At 2, it costs $45. And then at 3, it costs $55. And then again, 35. Yeah, that's good. 35. Okay, now I'm going to graph it with a line. Alright, cool. So now we have it graphed, okay? So we just took this table and we're representing it here. Now, what do you think the solution would be? Or more specifically, where do you think the solution would be? Where they intersect. Again, if the point is on both lines at the same time. So at the same time, 2 hours, they costed the same amount. So we have, again, it's on both lines at the same time at 1 point. So we said it was 245. And again, if you look here on the graph, the x value 2, y value 45, we get where these lines intersect. So that is our solution. So again, it is where this intersection is, that is our solution. That is the point in which both equations are true at the same time. So the steps to do this, the steps of an equation, are going to be put the equation into slope-intercept form. If it's not already, slope-intercept form, remember, is just y equals mx plus b. It's solved for y. And then we're going to graph each equation using the slope and the y-intercept, and plot multiple points. And then again, the solution is where the lines intersect. So I'm going to do an example for you, and then you'll try independent practice. Okay, so this one is solved for y, this one is solved for y. Good. Graph each equation. So now comes the fun part. I'm going to go ahead and graph this first one in pink and graph the next one in blue. I recommend you graph them in different colors to help you note it, pay attention to like which line is what. So my y-intercept here is -1. So I'm going to put a point at -1. And then my slope is 2 over 1. So that means I'm going to go up 2, right 1. I'm going to make this a little bit bigger. So up 2, 1, 2, to the right 1. Up 2, 1, 2, to the right 1. Up 2, to the right 1. Again, multiple points is going to make it easier to see where the intersection is at. Now, we can also go back the other way. You can see the pattern here, so I'm just going to follow it backwards. Okay, we got that line graphed. Now I'm going to go ahead and draw a line through it, again, because we're graphing lines here. And then now we can graph this blue line. So the y-intercept for this one was 5, so we're going to put a point at 5 on the y-axis. And then we have a slope of negative x, so -1 over 1. So that means we're going to go down 1 over 1. So from 5, from my y-intercept, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And you can already see where they're intersecting. Go ahead and draw a line through this one now. Woo! Oh no. Sorry, let me undo that. I accidentally had my eraser still clicked. There we go. Okay, so now we have both of them graphed. The solution is where the lines intersect. So we can find that by looking at this point right here. It's at 2 and then 3. Remember, ordered pairs are written 2, 3. So the solution to this problem would be 2, 3, x, comma, y. Okay, again, it's where they intersect. Some examples of a not solution would be like 6, 3. That's not where they intersect. 5, 9 would not be a solution. Even though it falls on this pink line and it's a solution to this pink line, again, the solution to a system is the point that makes both of them true. That point 5, 9 only makes the pink one true, so that's not a solution. Same goes with a point on the blue one. Let's say 4, 1. That would not be a solution because it only makes this blue equation true. It's only a point on the blue line. So that would be not a solution. Now, of course, we can go ahead and check this to make sure we're right. So again, we're saying 2, 3 is a solution. Well, again, remember, we can check if something's a solution by plugging it back into the equation. So I'm going to take 2, 3 and plug it in. So we have 3 equals 2 times 2 minus 1. We plugged it into that pink one. We get 3 equals 4 minus 1. 3 equals 3. That one's good. Now plug it into the blue equation. Y, whoop. We know what y is. 3 equals negative 2 plus 5. That gives me 3 equals 3. So, beautiful. Yes, 2, 3 is in fact a solution. We graphed it right. So, if you are fearful you did it wrong, all you need to do is take your point, plug it in, and if you get something true and true, nope, you did it right. No worries. Move on to the next one. If you got, one of these was right and then one of these you got like 3 equals 10 and it was not right, then it's not a solution to the system and you need to try graphing it again or reach out to me for help. Okay, so again, all you're doing is graphing one line, graphing the next line. So just like yesterday, it's just 2 problems in one. Graph one line and then graph the same line right on that same graph and then find where those 2 points cross. Again, make as many points as you can until you get to the intersection to make the point really, really clear. If you just try to like draw a line, chances are it'll be slightly off. So make sure you draw as many points as possible until you find their intersection. Okay, you have several practice problems down below. Again, solution, make sure you write it x, comma, y. It should be an ordered pair here. Try your very best. I should see 2 lines on every one of these graphs. All right, let me know when you finish and have a great day.